Okay.
It is recording now, so we'll just have part 2 of this. When I have an A, I have to get rid of the A, just like in completing the square. So here's my standard form. I want to go to vertex form. I'm going to have y equals. So my first step, I don't have to ignore the c because this equation doesn't have a c. My first step is to factor out a, no matter what a is. So I'm just going to say 3 parentheses. Then whatever I have left in the parentheses could sometimes be a fraction, but that's what I'll use to complete the square. So 3 times x squared minus x, yeah, 1x. And then I'm going to just leave space right there for completing the square. But if I add something, I have to subtract the same thing. Oh, Micah, did you have a question?
Yeah, well, oh, never mind. So I was going to ask, because there's x in both of them, but then add something, so that's what
Yeah. Right. Why don't we want to factor out 3x? Why don't we want to factor out all of that?
Because then you can't, it's not a perfect, like, you can't do the perfect square thing, and then you're a, because you need to just get the a out, too.
Yeah, look at vertex form, look where I'm going to. I want to have a perfect square, and I want a outside with no x, right? Good. So this is my goal, and if I factored out 3x, it wouldn't look like this. All right, so half of -1.
It's negative half of 5. Negative 0.5.
Yeah. So let's do this off to the side.
It's
Negative
1/4.
1/2. And then if I square that,
Negative 0.25.
1/2 squared is a 4th.
Oh, yeah, not negative.
So I'm going to add a 4th here. Now the trick is, what did I really just add to this equation? Did I add a 4th?
No, because you're subtracting a 4th from nothing. So technically you're not.
I'm adding a 4th inside this parenthesis.
Oh, yeah, so you're making
So
that
I'm
a perfect
actually
square.
adding 3 times a 4th.
Oh.
So I have to subtract 3/4. Now, if we wanted to prove to ourselves that that's correct, we could distribute this across and then try to convert it back into this form, and we'd see that it does work. If I have minus just a 4th, which is what I added here, we see that it doesn't work. I end up with a totally different equation if I resimplify. Okay. So now I have y equals, I'm going to leave my 3 here. Now I'm going to create my perfect square, which was x
Negative x minus 1/2
minus a half
and then minus
Plus
3/4. No,
squared,
minus
right?
3/4.
And then minus 3/4. Okay. So now my k is actually negative in this case. And that can totally happen. So here is my answer with an A. Any questions about that process? The trick now is just remembering I have to multiply this times this to figure out what I'm going to subtract over there. Let's do another one, but this time we'll have a C term. Okay. Okay. Y equals 7 x squared plus 28x plus 19.
Big numbers.
Whoa.
Okay. Convert this to vertex form.
Factor out the 7.
So I'm going to start in the same way that I started with my second case. I'm going to kind of isolate this.
Is it still case number
Y equals 7x squared plus 28x plus something plus 19 minus something. Now I'm going to factor out my 7. If I factor out 7 from this parentheses, I have x squared plus
3, 4,
4x plus something plus 19 minus something. Just copying that all down.
15.
How do I complete the square?
Add 4 and minus 4.
Yeah, so half of 4 is 2, and 2 squared is 4. So I'm going to add 4 here. Am I going to subtract 4 over there?
Yeah.
No.
No, why not?
Way more.
Because
4
you
times multiply
7.
4 by 7.
Right, I didn't really add 4. Remember, I factored out the 7. So what I actually added is 28. So I need to subtract 28 in order to keep the equation the same.
That number, and then you just.
Now I'm going to move up here. So now I factor what's in my parentheses. Y equals 7.
2
Good. X plus 2 squared. And then I have plus 19 and minus 28. So I have minus 9 if I combine those like terms. And that is vertex form of this standard. Any questions about that one? Okay, we have one more case, which I'll call case 4. It's a mathematical case. Does anyone want to guess what case 4 will be?
Case number. Well, case number.
So we said we've done A as 1, we've done A is greater than 1.
A is less than 1.
Yeah, and really, I actually didn't mean A is greater than 1. I kind of meant A is positive. But I probably won't be giving you, well, I definitely won't be giving you any tonight where A is a fraction or decimal. So now let's say, what if A is negative? What if A is less than 0? So now we're going to have a negative number out front. And this is really the same thing as case number 3. You just have to keep track of a negative number. So let's start out with a vertex form. Y equals, let's just say negative 1.
Wait, what about K?
Yeah, and so in this one, K is just really anything. So Y equals negative 1 times, let's just do X plus 1 squared, and then let's just have a plus 1. Convert that to standard form. Y equals, so remember, whenever I have an A, I'm going to expand this within parentheses. That way I don't forget to distribute. So X plus 1 squared is X squared plus 2X plus 1. And then I also have a plus 1 over here. Now I distribute. Y equals negative X squared minus 1 plus 1 y equals
Negative
negative x squared
minus 2.
minus 2x plus 0. This is my standard form version of this. So when I was completing the square and finding zeros, if I had two negatives, I would just get rid of it. I would divide by -1 and I would have all positives. Should I do that?
No, you can graph
then-
the parabola.
Because then your y would be negative and
Yeah.
that would be weird.
Right. If I divide this side by -1, I have to divide this side.
And then you just
I don't want
multiply-
negative
and then you just
y.
And
have
it's
to, like,
easy to graph a parabola. You
So,
can do the same thing, but it's
This is going to be one of the big differences with vertex form. And it's whenever you try to graph a parabola, you can't get rid of your negatives and you can't get rid of your greatest common factors. Because you would actually be changing the parabola. This parabola opens downwards. If I switched it to positive, then it's going to open upwards. So I've created a totally new parabola. When I'm finding my zeros, I can get rid of the negatives because 0 times -1 is 0. Doesn't change the other side. Okay, let's go the other way. So vertex form. I mean standard form to vertex form.
Negative 12 squared.
Y equals -3x squared minus 12x minus 13. Alright. Remember, I'm going to focus just on this part.
Negative
Y equals, so I'm going to pull out my -3, because that's A. And left in my parentheses I have x squared
plus 4.
plus 4x. Because -12 divided by -3 is +4. And I'm going to put plus blank. Outside the parentheses on this side I have -13 minus blank. Okay, y equals -3x squared plus 4x plus what? How do I complete that square? Half of 4 is 2. 2 squared is 4.
and then you're adding
Minus 13.
And then,
Okay,
oh, wait.
I'm going to add -3 times 4
Minus 12.
over here.
so you're gonna do
Plus
plus
12.
12.
So I have minus 12 minus a -12. Right. And just because I don't like minus a minus, I'm going to rewrite that as plus 12.
That's a beautiful plus.
It's a huge plus.
Disproportionately large. Now you just have y.
Now I'm going to come up here. Y equals -3. The whole reason I did this was so I could have a perfect square. X plus 2 squared minus 13 plus 12 minus 1.
Yay!
And I'm done. And that is our last case, and we have 1 minute left.
Don't erase it. Don't erase it.